Now we are going to talk about the rate law, how to write the rate law for a chemical reaction. So let's take a simple chemical reactions and write the rate law. So F2 in the gas phase react with 2 moles of ClO2 in the gas phase to produce 2 moles of FClO2 gas. This is our chemical reactions. Now rate expression and rate law are two different things. Now we are writing rate law. So rate law means the rate is related to the concentrations of the reactants. Rate is directly proportional to the reactant concentration. So rate is directly proportional to F2 concentration times ClO2 concentration. And here, to remove this proportionality sign, we can add a constant K. Rate is equal constant times concentration of F2 times concentration of ClO2. So this is we called rate law. In addition to these concentrations, we are adding the powers x and y. These x and y are not equal to the stoichiometric numbers. They are different values x and y. We call x and y orders of the reaction. They are reaction orders. This x is the exponent, that is order of the reaction in terms of F2, and y exponent is order of this reaction in terms of ClO2. And if we add all the exponents of the reactants together, here only x and y, here x plus y, we call overall order for these chemical reactions. Now this is the rate law for this chemical reaction. The rate law relates rate with rate constant and concentrations of the reactants. Rate law is an expression that relates rate of the chemical reactions with rate constant times concentration of the reactants. So K is here rate constant. Rate constant. Now for this any kind of general chemical reactions, how to write the rate law? Let's write the general format of the chemical reaction. A moles of A plus B moles of B goes to C moles of C plus D moles of D. For this general chemical reaction, let's write rate law. Rate law means the rate related to the reactant concentrations, rate and rate constant is equal rate constant K times A concentration times B concentration. This is the general format of the rate law for this given chemical reaction. Now x and y orders of this reaction we can calculate experimentally, and then we can find out rate constant value. Let's move on to one example here. The example here is this. The reaction of S2OH2 minus with iodide ion is. The reaction between these two reactants is given here. S2OH react with 3 moles of I minus. The products are 2 moles of sulfate plus I3 minus. So that is our chemical reaction, and it is already balanced adding coefficients. Now the question is, from the following data collected at certain temperature. So this data set is collected by experiment at a certain temperature. T is temperature. You have to determine the rate law first, and part 2 is calculate the rate constant K. Now these are the values given. So based on these values, let's calculate rate law and the rate constant. So first step is how to write the rate law expression for this given reaction. So we can write rate law, rate is equal rate constant times S2O8, order is X, times the next reactant is I minus concentration, order is Y. So this is the rate law for this chemical reaction. Now let's calculate X and Y using the given data set. So first, to calculate x, we need to ignore the y. So to ignore y, we have to select this is experiment 1, this is trial number 2, and this is experiment 3 or trial number 3. So we need to ignore I minus by selecting the same I minus concentrations. Then we can select 0.017, 0.017, and then we can easily calculate the x, the order in terms of S2O8, 2 minus. So what I'm going to do here is pick 2 and 3, 2 and 3, and then I'm going to divide 3 divided by 2. So let's write my rate 3 divided by rate 2. Right. So let's divide. Rate 3 is 2.2 times 10 to the power negative 4 divided by 1.1 times 10 to the power negative 4, and that is equal to, the expression is 2.2 times 10 to the negative 4, that is third one, S2O8 concentration raised to the power of x, and y is I minus concentration raised to the power of y, and we can substitute the values. S2O8 for this third step is 0.016 x and 0.017 y divided by 0.080 x, and this is 0.017 y. Now you can see 0.016 power x raised to the power of y, and it's the same thing raised to the power of y, we can cancel. So the answer is, we can divide these two. The answer is 2 is equal, so 0.016 divided by 0.80. So let's see using the calculator. 0.16 divided by 0.08, the answer is 2. Then if we divide these two, it is 2 to the power of x. Now we can calculate x exponent. X is equal 2 to the power 1 is equal x. So x is equal 1. So we found out the order in terms of S2O8 already. Now let's find out y, the order in terms of I minus. For that, let's pick two experimental data, two sets of data that is equal S2O8 concentration. So if we pick 1 and 2, experiment 1 and experiment 2, so in both S2O8 concentrations are same. So then we can calculate y in terms of I minus concentration. So let's apply the same method. I'm going to divide the equation 1 divided by equation 2. Rate 1 divided by rate 2. So this here, rate 1 divided by rate 2. So my rate 1 is again 2.2 times 10 to the negative 4 divided by rate 2 is 1.1 times 10 to the negative 4 is equal S2O8 concentration here in the first one is 0.080 divided by 0.080. Now x is 1, we already know that, and this is I minus c 0.034, order is 1 divided by, in the second experiment, I minus c 0.017 y. So we can cancel these two, those are equal. So the answer is 2.2 times 10 to the negative 4 divided by 1.1 times 10 to the negative 4, that is 2. So 2 is equal, this is 2 to the power of y. So the again answer is y is equal 1. So 2 to the power of 1 is equal to, so y is equal 1. Now we found x and y both. Now our rate expression is, we can write rate is equal rate constant times S2OH, 2 minus ion concentration. Its order is 1. We normally ignore writing 1, so it indicates 1 here, times I minus concentration. The power y, the exponent y is 1. So this is complete rate law for this chemical reaction. So first order in terms of S2OH 2 minus, and first order in terms of I minus reaction. Now what is the overall order for this chemical reactions? Overall order for this chemical reaction is, we need to add two orders together. So this is 1, 1, 1 plus 1, 1 plus 1 is 2. So overall second order chemical reaction, but in terms of S2OH first order, this is first order, overall second order. I hope you will understand how to how to find out the rate law. Let's go and substitute the values to find out rate constant. So our rate expression, I will write again here, rate is equal rate constant times S2OH 2 minus times I minus. That is our rate law. So if we pick experiment 1, 2 or 3, any of the experiment, we can calculate K then. So I will pick first one. The rate in the first experiment is 2.2 times 10 to the negative 4. It is given in the table, rate constant K. And in the first experiment, S2OH concentration is 0.080 times 0.034. So these are raised to the power of 1. Now we can easily calculate K is equal 2.2 times 10 to the negative 4 divided by 0.080 times 0.034. So rate constant K is, let's apply the values and calculator. So I will write the values. 2.2 times 10 to the negative minus 4, that is the value. You need to divide that number by 0.080 times 0.034. Then the answer is 0.08088. So let's write the answer into two significant figures, 0.081. That is our rate constant. So I hope you will understand how to calculate the rate constant and the rate law.